Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it. This one question cost marks on more papers than any other last year. Students muddled whether a quadratic had 2 roots, 1 root, or none at all, and lost easy marks doing so. Here's the promise. Calculate b squared minus for ac, make a short statement, and that confusion disappears. For a quadratic x squared plus bx plus c equals 0, the discriminant d is b squared minus for ac. You might recognize it inside the quadratic formula. X equals negative b plus or minus square root of b squared minus for ac, all over 2a. That square root controls everything. If what's under it is positive, we take 2 different square roots and get 2 distinct real roots. If it's 0, both signs give the same root and we get a single double root. If it's negative, the square root isn't real and there are no real roots. Simple rule. D greater than 0, 2 real roots. D equals 0, 1 real root double. D less than 0, no real roots. Now, for short worked examples so you can hear what to write and why it earns marks. Example 1. X squared minus 5x plus 6 equals 0. Here is 1, b is negative 5, c is 6. Calculate d equals negative 5 squared minus 4 times 1 times 6 equals 25 minus 24 equals 1. D is positive and a perfect square. So, 2 distinct real roots, and we can factorize quickly to x minus 2 times x minus 3 equals 0, giving x equals 2 and x equals 3. That's efficient and tidy on the paper. Example 2. 2x squared plus for x plus 2 equals 0. A is 2, b is 4, c is 2. D equals for squared minus for times 2 equals 16 minus 16 equals 0. D equals 0 means a double root. The quadratic touches the x-axis at one point. You can give the root as x equals negative 2a. Here x equals negative 4 divided by 4 equals negative 1. Make the statement d equals 0, so 1 real double root x equals negative 1. Example 3. X squared plus x plus 1 equals 0. A is 1, b is 1, c is 1. D equals 1 minus 4 equals negative 3, which is negative. That tells us there are no real roots. The parabola sits entirely above the x-axis. If A is positive, instead of forcing messy algebra, write D equals minus 3 less than 0, so no real roots. Sketch shows curve does not meet x-axis. That statement alone often wins method credit when the mark scheme asks for the nature of the roots. Example 4, 3x squared plus 2x minus 1 equals 0. Compute d equals 2 squared minus 4 times 3 times negative 1 equals 4 plus 12 equals 16, positive and a perfect square again. So 2 real rational roots. Use the quadratic formula or factorize. X equals negative 2 plus or minus 4 divided by 6, giving x equals 1/3 and x equals negative 1. State your calculation first, then show the formula substitution. Examiners like that order because it shows the decision process. The exam technique exactly what picks up marks. For a discriminant question, examiners usually allocate marks like this. M1 for correct substitution and evaluation of D, M1 for the correct method to find roots or conclude their nature, and A1 for the final answer or statement. So even if you can't finish the roots, writing D with your arithmetic can capture that first mark. A short model sentence to copy onto the paper. D equals b squared minus for AC equals since D greater than 0 or equals 0 or less than 0. There are two distinct real roots or one double root or no real roots. Therefore, use factorizing, quadratic formula or sketch as appropriate. Common traps to avoid: arithmetic slips when calculating b squared minus for AC. Always show the intermediate subtraction. For example, write 25 minus 24 equals 1. Don't forget the sign of b when squaring. Write -5 squared so markers can follow your working. Also avoid saying no solution when d is less than 0. Prefer the phrase no real roots. That precision matches what the mark scheme expects. The quick win. A checklist you can run through in every quadratic question. 1. Calculate d first and write it on the paper. 2. If d greater than 0 and d is a perfect square, try factorizing immediately. 3. If d equals 0, state one real double root and give x equals minus b over 2a. Sketch the vertex touching the x-axis. 4. If d less than 0, state no real roots and sketch a parabola not meeting the x-axis. Final step, always substitute one root back into the original equation as a 10-second check to catch careless errors. Don't skip the check. Quick demonstration of that 10-second substitution check. If your root is x equals 2, put x equals 2 into x squared plus bx plus c and confirm it equals 0. If it doesn't, retrace your arithmetic. That small habit catches around 90% of sign and calculation mistakes and can turn a lost mark into a gained one. News recap. Exam report. Examiners repeatedly flag two recurring errors in their reports. First, students solve and give numbers but forget to state the nature of the roots. Second, arithmetic on b squared minus for a is done in the head and is wrong. Both are avoidable. Using the discriminant as your first step and writing the calculation clearly recovers marks even when solving the roots is messy. Examiners love that clarity. That's your quick win for today. Calculate d first, state what it tells you, then choose factorizing, formula, or sketch. Stay curious. Until next time, trust the process and nail that exam. If this helped, share it with a friend who's revising. You'll find more worked solutions and a downloadable discriminant checklist at jcacademyline.co.uk. Go and grab the PDF after this episode.